Okay, hey guys, we're doing chapter 3 review. We did the first page and I wasn't recording, so I'm going to start recording now, and then as soon as we're done, I'll go back through and I'll go to do the first 8 with you. So, number 9, we are doing just the median. But we got to go in order, right? These are not in order. There are, how many numbers? 20 numbers? Okay, I'm going to go, yeah, I'm just going to go in the same line as they have now. What's the smallest? 15? Okay, 15 next. I see a 24. I see a 20 and a 24. So 20, 24, 25. There's a couple 25s. There's 1, 2, 3, 4 25s. So 1, 2, 3, 4 25s.
And you got 5 27.
I got 1, 2, 3, 4, 5 27. So 27, 27, 27, 27, 27. I'm doing this exactly the same way as what they had set up before, right? 2 28s, 28, 28, 29, a 30, 3 31s, and a 35. And now I know I have them all because I did them exactly the same setup as what they had. Okay, median. I have 20 numbers, true? Am I going to have an exact median? No, I have 10 numbers over here and 10 numbers over here, and these are the numbers 1 through 10, and these are the numbers 11 through 20. It would be between the 10th and 11th number, right? My 10th and 11th number are 27 and 27, so 27 is my median. That wasn't that bad, right? Give us a bunch of those, right? I don't know. Okay. All right, find the range for the given sample data. This is too easy. Range, highest minus lowest.
55.
1310?
yeah.
Oh no, 1465. What is it? 1465, is that the biggest?
No.
What is it?
3.0.
No, it is.
1465 minus 555.
Yeah.
Yeah. Which is 910. No. Is that right? Right? Yeah. 910. That's my range. Range. That is all.
900. What?
910.
There's a 5 side.
There's
Oh,
555,
five.
not 565.
Haha.
See, those ones are too easy, but like it's easy to make a mistake on because like my mind plays tricks on me. Awful. Okay, this is gonna be the hard one. This is gonna be the one that you're really gonna have to remember. Are you ready for it?
I'm using my calculator.
That's fine. This is coefficient of find the coefficient of variation for each of the two data sets. I'm not even reading the paragraph. This is an automated menu versus a live agent. Okay, typically, which one is going to vary more? Things that are automated like by robots or things that are live people? Which one varies more? More variation. Live people, right? Okay, automated or robots are going to give you more consistency. So this number should have a smaller variation. This one should have a bigger variation. Does that make sense? I'm already kind of like guesstimating and seeing what these numbers are going to be, okay? So we're trying to figure out which one varies more. Okay, to find a coefficient of variation, all we do is take the standard deviation and divide by the average and then convert to a percent, okay? Or take it times 100, basically. The standard deviation divided by the average. Okay, so let's talk standard deviation. If you plug these numbers into your calculator, do you know how to do that? To find standard deviation and to find average. Standard deviation for the top and average for the top. I need to know what those two things are.
Standard deviation is 6.7.
6.7 for standard deviation. Average is something else.
No, that's the average.
That's the average.
6.7.
6.7 is the average.
Yeah, shoot.
What's the standard deviation?
3.0.
What?
3.0.
3.0. Okay.
Wait,
And then
standard deviation, the S,
S. Yep.
3.04.
Yep.
Yeah,
Yep. I'm pretty sure on the test I give you the standard deviation and average when I ask for coefficient of variation. So you're welcome. You're welcome. Okay. What?
I put both the numbers in at the same time.
On two different lists? Sure.
How do I?
Go one variable stats. Stat, calc, one variable stats.
Yeah.
Enter. Okay. Is it pulling from list 1? Sure. Hit enter. Enter. Calculate.
It's the same thing though.
What?
How do I get it from second list?
Okay. And then you go back
that's
and
what-
you go stat, calc, one variable stats. But then, what am I doing here? Second quit. Clear. Okay, I go stat, calc, one variable stats. Oh, you have to hit list 2. Second list 2. Enter. Ah. Why does yours do this? This is so silly. I don't like it. Stat, calc. List 2. There you go. You have to do parentheses around the list. So now it's pulling from list 2.
You're going to remember how to do that
Sure.
tomorrow.
Where are these apples?
Or just put them both into list 1, like at a time. What's standard deviation for the second list? Sorry. What'd you get?
1.1
What? 1.1? Okay.
and 4.3.
I got 4.27, so 4.3.
4.3.
It says to round to that.
Round to the nearest. Okay. Okay. All right. So here's the deal. This is how this works. This is why there's a discrepancy. Okay. Which one looks like it varies less, according to the standard deviation? The bottom one. But the numbers are smaller because it has a smaller average, right? This one has a smaller standard deviation, but its numbers are smaller. So it should have it should deviate less because its numbers are smaller, right? So that's why we have to do the coefficient of variation, where we take and relate those two numbers to each other. The standard deviation versus the average, right? So we take those numbers and divide. So this one we take 3.0 and we divide by 6.7. Here we take 1.1 and divide by 4.3.
Top one's wait, and then take it up to 100?
And then, yeah, just convert it to a percent.
Top one's 44 point.
44.8%. That has how much it varies. Okay, what's the bottom one?
25.6.
25.6%. That's the opposite of what I thought it would be. Automated should vary
It says
less.
It says
I got,
11.7.
why did I get 45.4 and 26.3?
Yeah. What?
Why did I get 45.4 and 26.3?
Did you use a further decimal place?
What was the real?
Did you use the full decimal?
I just used like the second decimal, my 2 decimals.
Then that's fine. You used a further decimal place than what we had.
Okay, I got 2 and 3.
Technically, I think we probably should have used 2 decimal places because Reese, I think we round to 1 decimal place at the very end.
That's what I did with my.
But if you round it at the beginning, I'm not gonna count it wrong because like you're showing to me that you know how the process works, right? So, find the coefficient for each
Will you give us
of the 2 data sets, then compare the variation. So which one varies more?
the top one, right?
Automated menu has more variation. More variation. Okay? Can you remember coefficient of variation is standard deviation over average?
No.
You can do that.
I will
You
now.
can remember. That's like one thing you have to remember. What?
My computer is not doing it anymore.
What? The standard deviation? I think I know what's wrong.
It just keeps,
You have to turn your turn your thing on.
my stat is on. I entered all the data and then I was done to hit enter and then data. It just
Go second. Oh, and your data's gone? Did you go back to your list? Is it gone?
I'll show you. Like it's weird. I'll go over there.
Boo. I don't know. Let me look at it here in a minute.
It says calculating and I just go blank.
I'll look at it here in a bit. Okay. All right, let's do these last 3 or last 4 and then we'll go back.
Yeah, how are we supposed to get that one?
If you are in the 66th percentile,
66.
that means 66% of people are what?
Above average. I don't know.
If you are if I go into the doctor's office and my kid's in the 3rd percentile, that means what?
2 people are below.
3% are below her, right? What percent are above her?
The rest?
90.
97%. Approximately what percent of apple diameters are greater
34.
than the 66th percentile? If they're in the 66th percentile, that means 66% of people are below her. Or 66% of apple diameters are less than that one, right? So that means only 34% of apples are bigger than that apple, right? Does that make sense? That's what they're just asking what a percentile is, basically. They're saying if you're the 66th percentile, what the heck does that mean? That means that many are below you, right? Okay, so what are above you? 34%. Got it? Okay, now we're getting some good questions. If the standard deviation for a set of data is 0, the standard deviation is 0, Which of the following things must be true? All of the data values are identical. All of the data values are negative. All of the data values equal 0. Or none of the above must be true since standard deviation cannot be 0. Can standard deviation be 0?
Wait, what is
That
standard
would make more
deviation?
sense. That wouldn't have
Unless all the data is the
Yeah,
same. It can.
It's A.
Can your standard deviation be 0?
Yes.
You can have a data set that deviates none at all.
I think
It
it's
can
A.
be
If I have like 5 grades in the grade book and every single one of them is a 90, is it deviating at all? No, my average is going to be 90. All of it's going to be exactly the same, right? My standard deviation is going to be 0. So A, all of the data values are identical. I would also argue that all of the data values could be 0. C could also be true because that would have a deviation of 0, right? So technically C is true as well. But A is the most logical answer. All of the data values are identical, okay? All right, let's go to 15 and then let's go back to 14. I think we've had 15 as a question already. If your score on the next stats test is a z-score, which z-score would you rather have?
2.
Why? What does 2 mean?
Above.
That means you're 2 standard deviations above the average. That's what I would like. C? Okay, 14 requires a little bit of work. Okay, we're given an SAT score and an ACT score, and they want to know which of these is true, okay? SAT tests, I'm going to do SAT over here, has a mean. Let's give it some variables. Mean is X bar, 1518, and a standard deviation of 325. ACT, on the other hand, has a mean X bar of 21.1 and a standard deviation of 4.8. This is the data that it gives me. Which of the following choices is not true? Oh, I hate it when they do that. You know what? I hate it when they do not true. I know. Which one's not true? So, because you look at the first one and you're like, oh, that's true, it must be it, right? But there's 3 answers that are true. You're trying to find the one that's not true. Okay. All right, an ACT score of 17.0, and we're talking about what the z-score is. So ACT score of 17.0, how do I find z-score?
Your
X minus X bar over the standard deviation. So if I'm talking 17, I'm going 17 minus 21.1 over 4.8. Am I going to be above or below average?
Hello.
So that means my z-score is negative 0.85.
Yep, so that one's
So
correct.
z-score of 0.85, that is true. I'm going to put a T next to it, which means that's not the correct answer, right?
B is correct.
Okay. The next one, let's go down to D. It has a z-score of negative 0.9.
Yep.
If we're talking X, my X is 1490 for an SAT score. 1490 minus 1518 divided by the standard deviation. And that means my z-score, does it come out to be negative 0.09?
Yep.
Okay, so each one of them, I am below average, right? Okay, so this is true, so that's not the correct answer. Now, just FYI, if this was an ACT test, right, or an ACT test question, which some of you guys are not even taking the ACT again, but B and C are saying the opposite of each other, true? True. So we know one of those has to be the incorrect answer, correct? Like they're saying the opposite, so one of those has to be my answer choice, right? Okay, all right. So, which one is better?
SAT.
Which one is better? Okay, let's talk.
Wait.
0 as a z-score is here. We're comparing two negative numbers. Which one goes where?
SAT.
The SAT is closer to 0.
This one is negative 0.85 is on this side, and negative 0.09 goes here. So, SAT is here and ACT is here. Which one is better? SAT, right? SAT is the least, like this is bad land. This is bad over here, right? These are good scores, right? We want to be 2s, right? You said we want to be a 2 on the Z-score chart, right? We want to be over here. That's bad. SAT is better than ACT. So, which answer is?
Wrong. C or B.
B is wrong. This is true. SAT is better than ACT, so that's true. So B is the answer choice. Lots of work, right? 14 was B. Got it? Beautiful? Okay, all right. Study over that. Make sure you look over coefficient of variation. You know how to do percentiles and converting, and you know what z-score is. Like how to do z-score. Those like 3 things. Percentiles, I'll give you the formulas for some of the other ones, but percentiles, coefficient of variation, and z-score. Make sure you know how to do those. Okay? Study over those. All right, I'm going to go back to the front page, and then I'm going to help Aubrey figure out how on her test to do that. Put it in my tray.
You want him?
No. Is that the review, Brian, or no? I just need 3, 3 in the box plot. So if you're not done with those, put them in my tray. If you're done.
You don't want to review?
What? Yes.
Do you want to review this?
No. You look that over. What? Yes. Okay. All right. Number 1. You people watching this video, it says find a box, like construct a box plots, including the 5-number summary. Here's the 5-number summary. This is what we came up with. I think maybe you know how to do that, but check those with what you come up with. Okay. Make sure you can make sense of that. All right. Number 2, it says wants you to find standard deviation for these 5 numbers. The formula that we will use for standard deviation, I wrote over top of it. I will give this to you. You don't have to memorize this formula, but this is what it looks like, and then n times n minus 1. Okay, so n was 5 in this case, so 5 goes here, 5 goes here, 5 minus 1 is 4. That's where we come up with these numbers. Okay, now we took all 5 of those numbers and we put them into a chart that looks like this. We had the x chart and we had the x squared chart. So 7, 7, 2, 5, 1 added up to be 22. If we square those numbers, 49, 49, 4, 25, 1, those add up to be 128. Okay, now knowing the difference between this guy and this guy, superly important. This is the sum of all the x squared values. That is 128. So that goes in this spot right here. And then the sum of all the x's is 22. If we square that, that's 484. Okay? Then we do this square root thing, and that ends up being like 2.79 or something. Okay? Know how to plug that into your calculator so you can check your answer. Okay? So there's that. I said if they ask for variance instead, you just square that number, right? Hopefully that's a thing. All right. Number 3. The 56th percentile is 0.56. You take that times 40 numbers because there's 40 numbers in this data set, which is 22.4. We round that up to the next number, which is the 23rd number. And the 23rd number in my data set, 72 would be 20. 21, 22, 23 is 74. So 74 is the correct answer for that. Okay? All right, I went through that really fast. So pause if you need to. Collect your thoughts. Here we go. Use the given sample data to find Q3. All right. They did not give this to us in the correct order, so we had to reorder it. And so we did that right below each one. Okay, so Q3, there are 8 numbers, which means if I go to find my median would be between these two, which would be 53.5. We throw out the median, and when I'm finding Q3, I use those 4 numbers to find Q3, which would be in between these two, and we got 61. And that is Q3, and that's all we had to find. Okay, number 5, we're talking about different categories, okay? There are 4 different categories that we have going on here. We have a regular test, we have a final, we have a project, and we have a homework. Okay, those are the 4 categories that we have. Now, it does not give me what the regular test score is. It says we earned grades of 84, 78, 84, and 72 on our 4 regular tests, okay? Which means I have to, and I erase this, which means I have to add those 4 together and divide by 4 to get my average test score. So 79.5, that is my average test score, okay? Then I earned a 78 on the final, which is here. I earned a 86 on my project, and combined homework assignment was 87. So 86 and 87. And then it goes on to tell you that these are the weights for each one of those, okay? So then all I do is I multiply these together, and I get that answer. And I multiply these together, and I get that answer. And I multiply these together, and I get that answer. And then I add these up. And technically I divide by 100% because that's what these weights add up to be. But you don't have to divide by 100% because 100% is just 1. So I'm adding these together, and I get 81.2 as a grade for that section. Okay, so that's a weighted average. Then on number 6, I have a different weighted average, which tells me these are my grades. So I wrote them here. Whoop. And then these are the weights. So I wrote that here. Whoop. But I can't take B times 4. because that would just be 4B and that wouldn't make any sense. So they've assigned numbers, they've assigned values. They say A is worth 4 points, B is worth 3, C is worth 2, D is worth 1, F is worth 0, whatever. So I cross these off and put their respected values, and then I multiplied together. 3 times 4 is 12, 3 times 5 is 15, etc. going on. And if I add these guys up, that's 45. Now, tricky part, do I divide by 13? Do I divide by 19? You have to divide by the weights, because if somebody would come into these same classes and get different grades, these numbers would change, right? This 13 is going to change. It's not going to be 13 every time, but this 19 will stay the same. So I'm going to divide by 19, and we got a 2.37. That is not a great GPA, but that's what they got, okay? Because they're getting, like, they only had one A, and the A that they got was in a 1 credit hour class. So great, but maybe try harder in some of the other ones, right? Okay, 7. Human body temp has a mean of 98.2. I'm just gonna put that in the middle here, 98.2. And a standard deviation of 0.62. That means that's what I'm adding each time, right? Or subtracting each time, 0.62. Sally's temperature had a z-score of negative 1.5. That means Sally is negative 1.5 standard deviations below average. So she is right there, okay? But one standard deviation we know is 0.62. A half of a standard deviation would be half of that, which is 0.31. So what I'm going to do is I'm going to take 98.2, and I need to subtract both of those values to get to a different point, and we got like 97.27 is what that is. Okay, if I subtract those two, 97.27. I'm going below and below again, okay? All right, so that's my z-score. And then the last one was pretty easy. Find the mean for this data set. You're just adding those up and dividing by the number of numbers. So 56.7 is what we got. Okay, that is the front side. I went through that really fast, but if you need some more assistance, I can answer more questions tomorrow, but we're going to test tomorrow. Okay, goodbye.